This is the last problem on the projectile review. Number 3. It says a rock is thrown with a speed of 50 meters per second at an angle of 60 degrees above the horizontal from the top of a 100-meter high building. Okay, so here we go. There's a 100-meter high building. Okay, rock is thrown at an angle of 60 degrees at 50 meters per second. We want to know the following things. We want to know, number 1, or A, rather, the horizontal speed of the rock. So that's Vx, that's what we're looking for. B, we want to know the vertical speed of the rock after 5 seconds. So that's Vy, Vfy at 5 seconds equals question mark. C, we want to know where is the rock after 5 seconds. Donde está rock? We want to know where the rock is at 5 seconds. And then the last thing we want to know is the distance in the x from the building. How far from the building does it land? Alright, so step 1, number 1. On all of these problems, remember that if we have it at an angle, the first step is to break those up into components. So Vx equals 50 cosine 60, Vy equals, Viy rather, equals 50 sine 60. So we should solve those real quick. 50 cosine 60 is 25, and that's in meters per second. And Viy then would be 50 sine 60, and that would be 43.3 meters per second. Alright, so we've got both of those. Got them broken up. First thing we're going to look for is Vx. Well, that's convenient because I just found it. So that would be 25 meters per second. There we go. Got Vx. Now, for the trickier one, we've got to figure out what the final velocity is. You might want to write these numbers down because I'm going to be moving back and forth. But the final velocity in the y at 5 seconds is what we're looking for next. So Vfy at 5 seconds. Well, I know the time. This is convenient. I don't have to solve for the time. It's 5 seconds. What formula would I need to solve for in order to find the final velocity in the y? Well, if you remember, the only formula with the final velocity in the y is ay equals Vfy minus Viy divided by t. Okay, so now we need to fill it in. Negative 10 meters per second squared equals Vfy, which is unknown, minus the initial velocity in the y, which is this 43.3, divided by the time, which is 5 seconds. So, multiply the 5 up, we get, I'm just going to bring this up here, you get negative 50 meters per second equals Vfy minus 43.3. And so we would then add 43.3 to the other side, and we get negative 6.7 meters per second equals the final velocity in the y at 5 seconds. Okay, so this is equal to 6.7 meters per second. Alright, keep in mind that this is, like, if this is our image of what's happening, this is not the final velocity at this point. It's the final velocity somewhere up here, right? Somewhere in the process of it being shot off the roof. It's not at the bottom necessarily. Alright, third thing it asks us is, where is the rock at 5 seconds? Alright, so at 5 seconds we're looking for dx and dy. So for dx, we know the velocity in the x is equal to distance in the x divided by time. Solve for distance in the x. The velocity in the x, if we look back at the beginning, was 25 meters per second. So 25 equals distance in the x times 5. 5 times 25 is 125 meters equals the distance in the x. Alright, so we get distance in the x. distance in the y. Distance in the y equals 1/2 ay t squared plus viyt. Alright? I don't know why that t doesn't want to cross. So there is another part here though, because we're looking for its height. So since we're looking for the height of it, we need to put in the 100-meter height of the building as well. So plug in our numbers. dy is equal to 1/2 times -10 times 5 squared plus the initial velocity in the y, which is 43.3. 43.3 times 5 plus 100. So if we plug this in, we should get 191.5. And this tells us that if this is our building, our ball at 5 seconds is 125 meters this way and 191 meters this way. Okay? And that's what we get. That's that's letter C. The last question is very, very complicated. That's the reason it's got an asterisk by it. How far away from the edge of the building does the rock land? Well, first let's redraw. So we've got our building. Alright, here's our rock. It's going to fly like this. So the distance in the x is right here. Now, you may notice that, here we'll do it in a different color, you may notice that, well, normally if we were looking for the distance of the x, we would stop right here. But it keeps going a little bit past that, so we have to include it. So we've got to figure out a time. How to figure out the time? Well, what I would recommend doing is figuring out the time to this halfway point right here. So this is where our velocity in the y equals 0. How long did it take to get here? So this is like a 3-step problem. First step, time to the top. Second step, figure out the height of the total height of the ball, the highest point for the ball, at the highest point. Okay? Step 3, find how long it takes to fall for that. So how long would it take to fall from that point? Then the last step, step 4, find dx. Okay? So let's take these one step at a time. So I've told you you've got to find the time to the top. Alright, so we've got a situation like this. We know the initial velocity in the y is 43.3. We know the final velocity in the y at this point is 0. Alright, so we should use ay equals vfy minus viy divided by t. We get -10 equals 0 minus 43.3 divided by the time, which is unknown, and we get that time is equal to 4.3 seconds. And this is the time to the top. So coming back here, the time to the top is 4.3 seconds, or 4.33 seconds. Alright, now we've got the time to the top. Alright, now we've got to find the highest point, because we need to figure out how long it's going to take to fall. How long does it take to fall from the highest point? So we got to calculate the highest point. Well, the highest point would be equal to dy equals 1/2 times ay times time to the top plus viy t top plus 100. This is the height of the building. So we'll plug all that in, and we should get dy equals 1/2 times -10 times, what would it be? 4.33 squared plus 43.3 times 4.33 plus 100 meter height. Okay, so this should get us the height of our fall. So if we solve for this, we should get dy is equal to 194 meters. Alright, so now we've got the height. So the highest point is 194 meters. Now we need to know how long it takes to fall from that height. Okay, so How long does it take to fall from this height? Well, we'll just solve this real quick. If it's falling from this point, the initial velocity in the y is 0 because it's falling. The distance in the y is 194, so we're going to solve for time. dy equals 1/2, yada yada yada. I'll show you this at this point. So 194 equals 1/2 times -10 times t squared, and we should get 194 divided by 5 square rooted equals t, and so t would be 36.2. So this is the time to fall is equal to 6.2 seconds, 6.23 seconds to be technical. And so this is the time to fall. Now, if I'm trying to find dx, which one of these do I do? What do I do? Well, if you remember, you need to know the total time in the air. So vx equals dx divided by the total time in the air. So we need to add these two numbers together to get the time in the air. Time in the air equals 4.33 plus 6.23, and we should get 10.56. That's how long it was in the air for, 10.56 seconds. So we'll come over here and say Vx equals dx divided by t. Vx was 25, dx is unknown, time is 10.56 seconds. Dx then equals 25 times 56, and so we should get 264 meters is the distance that it would land from the start. So it should be distance in the x, distance from the building is 264 meters to go to the very beginning. Alright, so let's go back and look, make sure I did this right. The velocity in the x is equal to the distance in the x divided by time. 25 was the velocity in the x for the problem. 10.56 seconds was the time it was in the air, so 264 meters total. Alright, I know this one was a little long, sorry about that. Alright, hope y'all have a good day.